Fahrenheit is a temperature scale based on one proposed in 1724 by the German physicist Daniel Gabriel Fahrenheit, after whom the scale is named. There exist several accounts of how he originally defined his scale. The lower defining point, 0 degrees, was established as the temperature of a solution of brine made from equal parts of ice and salt. Further limits were established as the melting point of water and his best estimate of the average human body temperature. The scale is now usually defined by two fixed points. The temperature at which water freezes into ice is defined as 32 degrees, and the boiling point of water is defined to be 212 degrees. A 180-degree separation, as defined at sea level and standard atmospheric pressure. By the end of the 20th century, Fahrenheit was only used as the official temperature scale in the United States, the Bahamas, Belize, the Cayman Islands, and Palau, as well as being the most common unofficial scale in many of the current and former U.S. unincorporated territories, as well as Great Britain. All other countries in the world, including Great Britain, now use the Celsius scale, defined since 1954 by absolute zero being minus 273.15 degrees Celsius and the triple point of water being at 0.01 degrees Celsius. Definition and conversions. On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit and the boiling point is 212 degrees Fahrenheit. This puts the boiling and freezing points of water exactly 180 degrees apart. Therefore, a degree on the Fahrenheit scale is 1/180th of the interval between the freezing point and the boiling point. On the Celsius scale, the freezing and boiling points of water are 100 degrees apart. A temperature interval of 1 degree Fahrenheit is equal to an interval of 5/9 degrees Celsius. The Fahrenheit and Celsius scales intersect at minus 40 degrees. Absolute zero is minus 273.15 degrees Celsius or minus 459.67 degrees Fahrenheit. The Rankine temperature scale uses degree intervals of the same size as those of the Fahrenheit scale, except that absolute zero is 0 the same way that the Kelvin temperature scale matches the Celsius scale, except that absolute zero is 0 K. The Fahrenheit scale uses the symbol degree to denote a point on the temperature scale and the letter F to indicate the use of the Fahrenheit scale, as well as to denote a difference between temperatures or an uncertainty in temperature. For an exact conversion, the following formulas can be applied. Fahrenheit to Celsius divided by 1.8 equals degree C Celsius to Fahrenheit plus 32 equals degree F. An approximate conversion between degrees Celsius and degrees Fahrenheit is as follows. Fahrenheit to Celsius. Subtract 30 and halve the resulting number. Celsius to Fahrenheit. Double the number and add 30. This formula gives an answer correct to within plus or minus 2.8 degrees Celsius from 1 degree Fahrenheit to 100 degrees Fahrenheit and is exact at 50 degrees Fahrenheit. Divided by 2, divided by 1.8, equals 2.72 divided by 2, divided by 1.8, equals 0 divided by 2, divided by 1.8, equals 2.77 History. Fahrenheit proposed his temperature scale in 1724, basing it on 3 reference points of temperature. In his initial scale, the 0 point is determined by placing the thermometer in brine. He used a mixture of ice, water, and ammonium chloride, a salt, at a 1:1 ratio. This is a frigorific mixture which stabilizes its temperature automatically. That stable temperature was defined as 0 degrees Fahrenheit. The second point, at 32 degrees, was a mixture of ice and water without the ammonium chloride at a 1:1 ratio. The third point, 96 degrees, was approximately the human body temperature, then called blood heat. According to a story and trivia questions in Germany, Fahrenheit actually chose the lowest air temperature measured in his hometown Danzig in winter 1708-09 as 0 degrees Fahrenheit. and only later had the need to be able to make this value reproducible using brine. This is one explanation given why 0 degrees Fahrenheit is minus 17.78 degrees Celsius, but the ammonium chloride cooling temperature actually is minus 3 degrees Celsius, whereas that of NaCl is minus 21.1 degrees Celsius. The other explanation is that he did not have a good enough brine solution to obtain a eutectic equilibrium. Exactly. In any case, the definition of the Fahrenheit scale has changed since. According to a letter Fahrenheit wrote to his friend Hermann Boerhaave, his scale was built on the work of Ole Romer, whom he had met earlier. In Romer's scale, brine freezes at 0, water freezes and melts at 7.5 degrees, body temperature is 22.5, and water boils at 60 degrees. Fahrenheit multiplied each value by 4 in order to eliminate fractions and increase the granularity of the scale. He then recalibrated his scale using the melting point of ice and normal human body temperature. He adjusted the scale so that the melting point of ice would be 32 degrees and body temperature 96 degrees. So that 64 intervals would separate the two, allowing him to mark degree lines on his instruments by simply bisecting the interval 6 times. Fahrenheit observed that water boils at about 212 degrees using this scale. Later, other scientists decided to redefine the scale slightly to make the freezing point exactly 32 degrees Fahrenheit, and the boiling point exactly 212 degrees Fahrenheit or 180 degrees higher. It is for this reason that normal human body temperature is approximately 98 degrees on the revised scale. The Rankine temperature scale was based upon the Fahrenheit temperature scale, with its 0 representing absolute zero instead. Usage. The Fahrenheit scale was the primary temperature standard for climatic, industrial and medical purposes in English-speaking countries until the 1960s. In the late 1960s and 1970s, the Celsius scale replaced Fahrenheit in almost all of those countries, with the notable exception of the United States, typically during their metrication process. Virgin Islands for everyday applications. For example, U.S. weather forecasts, food cooking, and freezing temperatures are typically given in degrees Fahrenheit. Scientists, such as meteorologists, use Celsius or Kelvin in all countries. Early in the 20th century, Halsey and Dale suggested that the resistance to the use of centigrade system in the U.S. included the larger size of each degree Celsius and the lower 0 point in the Fahrenheit system. Canada has passed legislation favoring the international system of units, while also maintaining legal definitions for traditional Canadian imperial units. Canadian weather reports are conveyed using degrees Celsius with occasional reference to Fahrenheit, especially for cross-border broadcasts. Virtually all Canadian ovens make legal use of the Fahrenheit scale. Thermometers, both digital and analog, sold in Canada usually employ both the Celsius and Fahrenheit scales. Also, in some instances, temperatures are still expressed in Fahrenheit. Within the European Union, it is mandatory to use kelvins or degrees Celsius when quoting temperature for economic, public health, public safety and administrative purposes, though degrees Fahrenheit may be used alongside degrees Celsius as a supplementary unit. For example, the laundry symbols used in the United Kingdom follow the recommendations of ISO 3758-2005, showing the temperature of the washing machine water in degrees Celsius only. The equivalent label in North America uses 1 to 6 dots to denote temperature with an optional temperature in degrees Celsius. Within the unregulated sector, such as journalism, the use of Fahrenheit in the United Kingdom follows no fixed pattern, with degrees Fahrenheit often appearing alongside degrees Celsius. The Daily Mail, on its daily weather page, quotes Celsius first, followed by Fahrenheit in brackets. The Daily Telegraph does not mention Fahrenheit on its daily weather page, while the Times also has an all-metric daily weather page but has a Celsius to Fahrenheit conversion table when publishing news stories. Much of the UK press adopted a convention of using degrees Celsius in headlines relating to low temperatures and Fahrenheit for high temperatures. In February 2006, the writer of an article in the Times suggested that the rationale was one of emphasis. -6 degrees Celsius sounds colder than 21 degrees Fahrenheit, and 94 degrees Fahrenheit sounds more impressive than 34 degrees Celsius. Unicode representation of symbol. Unicode provides the Fahrenheit symbol at code point U plus 2109 degree Fahrenheit. However, this is a compatibility character encoded for round-trip compatibility with legacy encodings. The Unicode standard explicitly discourages the use of this character.